Hello kiddos, and welcome back to yet another retro channel. Today we're going to be taking a further look at some of Copper Dragon's LumaCode boards. Since the last time I spoke to you, Copper Dragon has been working on an update for the vic-ii-digitizer. I've been providing him with some testing to help him along in that process. So one of the boards we have today is the revised vic-ii-digitizer. The second board we're going to be taking a look at is the TIAdigitizer. This one is for the Atari 2600. The third is the ULAdigitizer. I will be installing that into my ZX Spectrum 48K rubber key. And finally, the TMSdigitizer. That works with the TMS 9918, 9928, and 9929 chips, and I'll be installing that into a Texas Instruments 994A. So let's get to it. Eagle-eyed viewers may be asking themselves why I have the Commodore 64 on the bench. Well, that's because I believe I mentioned this in the first video, but if I didn't, I apologize. There is some information going around, and I heard this from that down under dag Mark from the Retro channel. Sorry, Mark. He mentioned that there may be some problems with the LumaCode vic-ii-dizer and the vic-ii Kawari. Now, that would only apply to the vic-ii Kawari Mini. As most of you will know, the vic-ii Kawari large board has its own DVI-compatible HDMI output, so you wouldn't even need a LumaCode board for that. But if you're using the Mini, you might want to add the LumaCode board to get HDMI output out of the Mini board. Unfortunately, Mark is right. My experiment did turn up that it doesn't work with the Kawari Mini. It works fine with the original 6567 R8, but when I put in the Kawari Mini, even set to, well, actually set to various different modes, it doesn't produce a LumaCode output, or at least one that's recognizable. I did try several settings on the Kawari. I tried flashing the firmware on the Kawari, and I also tried settings on the RGB to HDMI, and wasn't able to actually come up with a usable output from the Kawari Mini. So for the time being, I'm going to say that it looks like the vic-ii-digitizer is not compatible. Rather unfortunate, because it would be a way, if you're not able to get a hold of a large vic-ii Kawari board and you want HDMI output, it would be nice if this vic-ii-dizer would allow that, but it doesn't appear to, at least not at the moment. Now, things may change in the future.
Hello, me from the future here. I've had to get in touch with Copper Dragon to ask about an issue with the ULAdigitizer, and when I did, he pointed me to some additional information regarding the Kawari. It turns out he's actually been in contact with Randy Rossi, the owner and maintainer of the vic-ii Kawari project. The incompatibility between the Kawari and his vic-ii-dizer has to do with access timings that don't exactly match between the original vic-ii and the Kawari FPGA replacement boards. It's not something that either Copper Dragon or Randy can easily fix in their designs. However, they may have worked out a possible solution. Randy has recently split off another fork of his design that he calls the plain old Vic or POV version. This one would be basically the same board as the Kawari Mini, but with all the additional features stripped out, RGB output, additional graphics modes, etc., so that it basically mimics an original VIC-2 and nothing else. He's proposed to modify that board and its firmware to output Copper Dragon's LumaCode encoded signal on its Luma pin. They've been in discussions with each other on how to do this, so look forward potentially to another version of the Kawari to come out in the near future with LumaCode as an output option.
So give me a moment and let me bring up the VIC-20 and we'll start with that. Okay, so if you remember from last time, we installed the vic-ii-digitizer into this VIC-20, and in the meantime just to get ready, because eventually this thing will keep the vic-ii digitizer. I mentioned that I was going to 3D print a port bracket, and I did. So here's the new port bracket, and I have drilled a hole to mount the LumaCode digitizer's RCA jack. And we were having problems with a couple of the cartridges, both the penultimate cartridge and Omega Race. When you started them up, the vic-ii digitizer was unable to recognize the initial screen mode. So let's go ahead and give you a demonstration of that, just so we're still on the same page here. So I'll go over to my comparison screen now, and we have the LumaCode digitizer hooked up. It is set to vic-ii mode. So if I power this up, we should see both the composite. I have the composite coming out here, and the LumaCode coming out here. So I have both of them enabled at the same time. So I can start this up. But there we have both screens. When the machine is just powering on to basic, we get a pretty good result. So let's go ahead and try Omega Race. Now this should show up in the composite, but not in the LumaCode. So there it's showing up in composite, but it's not showing up in LumaCode. So we can also look at the penultimate cartridge, and that should do the same thing. So you can see the penultimate cartridge came up, and just for comparison's sake, we will try a cartridge that does work, or did work. Make sure we're still in the same condition we were when we left off last time. Mole Attack should work. On both composite and LumaCode. There. Yeah. That static you're seeing is a bit of a bad connection. You can twiddle the RCA jack here, and it goes away. But there you see, both for the just standard basic and for Mole Attack, it works, and for the penultimate cartridge and Omega Race, it doesn't. Now, I sent this kind of testing to Copper Dragon, and he used that to modify the firmware in the new version of the digitizer. So what we're going to do is we're going to switch over to the new vic-ii digitizer, and as you can see here, that's firmware version 2.1. So we need to pull the old, make sure our power's off, pull the old digitizer, and fortunately Copper Dragon made the RCA jack with these little DuPont connectors so that I can simply disconnect those and I'll be able to reconnect the new. So I need to take that off. And we can pop this out of here carefully. The RF can makes it difficult, of course. I could remove that. It's really not that vital anymore. Okay, here's the old digitizer. We'll remove the 6560 VIC chip. Set that aside. Get our new digitizer. Make sure we line up the notch. While I'm doing this, I should mention what Copper Dragon told me is it seemed to be an issue with those the penultimate cartridge and the Omega race seemed to be coming up in double height character mode. So that was what he thinks was causing it, and that's what he's corrected on this board, made it a little more forgiving. Okay. Now, white is center. Okay, I think that should do it. Let's go ahead and try. We'll leave MoleAttack in. That's the one, again, like I said, that worked on both the LumaCode and composite mode. So, do we get MoleAttack? Oh, there it is. Just took it a while. Okay, so MoleAttack still works. Try it now with just booting to basic. Okay, that still works. Takes it a little longer. Seems to take a little longer to sync up now, but once it does, it's fine. Okay, the next test will be Omega Race. And looks like we're getting. Come on, you can do it. Again, it takes a little longer to sync up now than it did before, but there is Omega Race working. And finally, we'll try the penultimate plus cartridge. And there we go. Penultimate Plus is working as well. Now, I think I need to tweak the palette a little bit on the RGB to HDMI because the colors are slightly off, but not bad. So, sitting here wondering why I'm not getting sounds. Because I forgot to turn on the headset. Alright, so that is the revised VIC-ii digitizer, working well. I would test it with more games if I had more cartridges. I do not. Once you get into the penultimate cartridge, it stays synced, so any of the games that I could run from that are just going to work. If I had more cartridges that failed, I could show those, but I don't. Okay, the next machine we're going to look at is my 4-switch Woody, my Atari 2600. In the Atari 2600, we will be using the TIAdigitizer, and that will go under the TIA chip, which is right here. You're looking for the CO10444 or the CO11903. Those are the TIA chips. In my case, it's a 10444. So what we need to do is pop out the TIA chip. Now this machine has already been composite modded, so I'll have a composite out to show you a comparison. Pop out the TIA here. Okay, there's my TIA chip. And here is the TIAdigitizer from Copper Dragon Rev 1. Again, as always, make sure that you line up the notch on the chip with the notch on the digitizer. Insert the TIA. Careful not to bend the pins. And then notch on that socket is there, so we're going to insert it this way. Yep, I'm going to need an additional socket here, as the little board is interfering with the, I believe that's the CPU. The Atari 2600 uses, I think it's a 6507, which is a modified version of 6502 with not as many pins. So I believe that's the CPU. All right, let me get another socket. Let's put the digitizer into the socket. There, that should give me the extra height that I need. There we go. And now, I'll need some power. And let's go ahead and see if we get any output here. Oh, I need a cartridge, don't I? Pardon me for a moment. Okay, we have Donkey Kong. Now, we should be getting output. Once the RetroTink is synced up, yes, we are getting output, so we're good. Now, the TIAdigitizer has an RCA output, and we will connect loose. and see if we get output. I already have the RGB to HDMI set to Atari 2600 LumaCode mode. So let's look at the comparison and see what we get. Okay, there is LumaCode output. Where's my joystick? I want to make sure this looks okay. Yeah. Use this old Spectre Video quick shot here. Okay, there it is. It looks good. I'm not sure what's going on with the audio, to be honest. I think it's something to do with my little injector. Yeah, that's something to do with the audio injector that I'm using. I'm going to have to work on that. Maybe the cabling I'm using between the Atari and the injector. Sorry about that. But that's the TIAdigitizer, and it seems to work just fine. Now, I have, as you can probably see, already done a case mod on this 4-switch Woody to put audio and composite jacks in the back, so I normally would not consider modifying the case, but since I've already modified this one a while back, I will go ahead and simply put another hole in the back here for the LumaCode output, and just mount this jack down there, and this machine will be LumaCoded. So there's another nice LumaCode digitizer for the TIA chip in the Atari 2600. As you know, there are different models of the 2600 and different main boards. Some have a main board and a sub, a switchboard, and so you'll have to find your TIA chip, which is, again, like I said, the CO10444 or the CO11903. So that's the chip you're looking for. Okay, I guess now we move on to probably the easier of the next two will be the ULAdigitizer. Okay, boys and girls, what we have here is my Sinclair ZX Spectrum 48K rubber key. This is an issue 2 board. So we're going to install Copper Dragon's ULAdigitizer, and that goes underneath the ULA. Now, in the case of the ZX Spectrum 48K, the case creates space constraints, so he couldn't design it as an interposer board like he did for the others. What we have to do with this one is we have to mount it underneath. Now, the ULA notch is to the back of the board here, so we line up the notch in the ULAdigitizer and place it in there, and then what we have to do is we have to connect wires between these pads on the ULAdigitizer match up with pins on the ULA, so we have to connect with a small wire between the pad and the pin. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of those. And then these two are the LumaCode out. So I have to do some fiddly little soldering here. And I think I'm going to actually suggest to Copper Dragon that he modify this board. What he can do is if he widens the board and creates vias, 40 vias, 20 down each side, and then just plate the vias for the pins that need connection, he can make this actually easier to do. Connecting this with wires is going to be kind of a pain in the butt. But if he were to do that, widen the board out, create the vias, and just plate the vias that need to be connected, that would make this a lot easier. So I'm going to suggest to him that he do that. Now, whether he'll take my suggestion, I don't know. But that's what we're going to do here. So first thing I need to do is tin up all these little pads. And I've already put flux on the pads, so hopefully we'll be able to tin these up pretty easily. I have switched to a finer tip on my soldering iron than I normally use because we're working in such close quarters here. Okay, now I'm going to take, this is wire wrap wire, very narrow gauge wire, and I'm going to tack it onto each one of these connections and then clip it off with enough slack to allow me to connect it to the pins later. Okay, now that I have the connections, I can bring back the Spectrum and line this up. Start tacking down these wires to the ULA pins. Go ahead and add just a touch more solder. Now I'm going to check continuity, make sure that everything is connected. Okay, all those look good. Now, the kit comes with a length of ribbon cable, two wire ribbon cable, and RCA jack. And we are going to connect these. Make sure we have the right one. This way around. Yep. So Luma, the one labeled as Luma, goes to the center, and of course ground goes to the outside. So they go in this order. And once I have a final disposition, I'll use some Kapton tape, but for now, that is what we need. Now, for my next trick, so that was a bit of an adventure. So I finished soldering the ULAdigitizer to the back of the Spectrum, and everything with that went exactly to plan. All the connections are correctly made. So I went to find the correct profile on the RGB to HDMI, and it turns out that the beta firmware that I have, which is the latest beta firmware, didn't contain a profile for the Spectrum 48K LumaCode. So I stepped away and I reached out to Copper Dragon, who did tell me that there was a newer version of the firmware, an alpha, not even a beta version, but an alpha version, available from ENSB's GitHub. So I downloaded that and put that on the RGB to HDMI, and lo and behold, there is a profile. So the next thing I did was hook the Spectrum up so that I would be able to show you the original composite mod compared to the HDMI output. And I ran into a little problem, and my composite was all out of whack. It was showing basically only green, and I worried that something had gone wrong with the LM1889N chip, which is the TV encoder. The ULA creates the video image, but the encoder is responsible for creating the composite output, and that's been known to go bad, and sometimes the way it goes bad is by showing only one of the colors. In this case, it was green. So I removed that chip and socketed it and put it back in, and there was no change. But the other thing that can cause that, I was told, or I've read about, was some adjustments to these potentiometers. So I fiddled with those for a while, and I finally managed to get the composite video back to something that looks like what it should be. So now, with the new profile on the RGB to HDMI and the composite video working, I'm ready to show you what this looks like. Now, be patient. This does take a while to come up. Let me put the keyboard back on so I can actually do something with the Dandinator once I get it booted. So, at the moment, I only have the LumaCode output coming out just on that original 2-pin going to the connector for the RGB to HDMI. What I'll do to make this permanent is I'll go ahead and cannibalize the RCA plug that's currently being used for component, or composite rather, but I didn't want to do that until I've been able to show you the comparison between the two. So we have the composite going through the retro tank, and we have the LumaCode to HDMI going through the RGB to HDMI on a direct capture. So let's see what we get when we turn on the power. And I have this powered through my bench power supply for now. So, like I said, give it a moment. There's the composite, and there is the LumaCode. You can see the composite, I still haven't got it tweaked all the way back in. It's still got a bit of a blue tint to it. And that flashing on the LumaCode, that is, again, that's some of the tweaking that I was doing. It affected the clock signals, and it doesn't seem to be 100% happy. So let me tweak that a little bit more. The clock frequency has to be right for the RGB to HDMI to lock on. And of course, I've got it set wrong. I think these two up here seem to affect the clock signal more. It's holding relatively steady right now, so no, there it goes. That also seems to be taking a little of the blue out of the composite sometimes. Well, I'm going to have to work on tweaking this, getting it steady. Seems to be holding at the moment. I may have to tweak that further, but that's just, that's a, you know, I know what that issue is, that blanking out. It's a issue with the clock. So if you see that, you know, take for granted that that's something that I can fix. It's in the Spectrum. It's not to do with the LumaCode digitizer board. So let's go ahead and load Manic Miner. Now I'm having trouble with the composite. Lost color. Well, that'll be up to me to tweak to get, well, I'm not going to worry about the composite because, as I said, I'm going to go ahead and cannibalize that connection for my LumaCode output. Bring those down so that they're a little less annoying. You are hearing audio both from the composite, which I believe is, we're backwards. I think I have composite shifted to the left or shifted to the right, and LumaCode shifted to the left. So you're actually hearing that the audio is relatively synced up between the two output methods, the composite and the RGB to HDMI. So there's not much difference in what you can see on the screen. There's not much difference in the lag between the two. So that is the ULAdigitizer. And again, I will continue to tweak that to try to get everything nice and steady, but that, like I said, is not a fault of the LumaCode digitizer. It's a fault in how I have the clock set up inside the Spectrum. So now on to, I hope, the TMSdigitizer. We'll see you back in a few. Okay, cats and kittens, what we have in front of us now is a deconstructed TI-99 4A. And I'll be honest with you, I've never taken one of these apart before. I have 3 of them. 2 of them haven't even been tested. This is the only one that was tested that I know works. It has some case issues, but we can deal with that later. So in this machine, this is a little bit of an oddball. Actually, it's a lot of an oddball. It has an odd power jack, and then the power board conditions it, conditions the power and returns the power to the motherboard. We have a TMS 9900 16-bit processor that's hamstrung by the fact that its only access to memory 16 bits at a time is to what I think is 256 bytes of SRAM here. The rest of the memory is called video memory, and that's where video is stored, and it's where programs are stored, shared, and the CPU only has access to it through the video subsystem 8 bits at a time. So again, an oddball computer. And then the chip that we're concerned with today is the TMS 9918NL, this chip right here. Now, this chip normally has a heatsink attached to it, rather beefy little heatsink that actually mounts to the underside of the RF shield, and then heatsink compound connects it to the chip. So this heatsink and this entire shield act as a heatsink for the TMS 9918. So I'm assuming that chip gets rather hot. So we won't be running it for long periods of time without any kind of heat sinking. And what we're going to do is install the TMSdigitizer. This Copper Dragon's LumaCode digitizer board for the TMS 9918, 9928, and 9929 video chips. And the first thing we need to do is attach the leads to it. Those go here, so I just need to solder those in. I'm going to go ahead, well, first, I did want to show, I'm going to show you that this is a working machine, and we do get composite video out of it. It has an AV jack, a 5-pin AV jack similar to the Commodore 64, Commodore VIC-20. Most of the pins do the same thing, so I can use the same cable that I use for the Commodore 64. There is one pin that's different and is very important. There is 12 volts on the same pin as the Commodore 64 uses for, I think it's S-Video Luma. So if you're using a cable that has S-Video and or has Luma and Chroma that come out of it, you want to make sure you don't use that on this, because you could send 12 volts to something that doesn't want 12 volts. But this cable is built, this cable little pigtail I've built is built without that pin being connected, so it's perfectly safe to use. Composite videos on the same pin, and audio is on the same pin as the Commodore 64 and VIC-20, so that cable is safe to use. So I'll go ahead now and start this up. It won't, the RetroTink won't sync in time to hear the opening tone, but the tone is obviously there because we're getting the screen. And I can go in and go to TI Basic, and we're good to go. So this machine is functional. So I'm going to go ahead and pull the keyboard off, so get it out of the way. And that keyboard is also fully functional. Now, pull the power. And we can pull the power board for the time being. We're left with just the motherboard, which we'll get to in a moment. And for now, we're going to go ahead and solder these two in here. Now, you'll want the center of the RCA jack to go to the via marked luminance, or LumaCode, LUM, and the shield to go to the other. So I've already marked these. The one with the black mark on it is Luma. Need my magnifier here because all the markings on this are very tiny. So Luma goes in the one closest to the notch, and ground goes in the other. And then we just need to add some solder. Solder, however you want to pronounce it. And that is the only soldering that's absolutely required for this installation. Now what we need to do is pop out our 9918. Okay, now I'm going to clean up these legs. They've got thermal compound all over them. Well, that should be good enough. And then I will insert the 9918 into the LumaCode digitizer, matching the notch to the notch on the board. Milled sockets are nice, but they're not very forgiving. I'm trying to insert a chip. I don't see any bent pins. I think we're good. Now, I don't know if you paid attention, but I did when I was taking this out. The notch goes to the bottom, and you can also tell that by the little arrow indicator here, indicating pin 1. So this is going to go into the socket. Ooh, we may have an issue. Yep, we have a clock crystal in the way. Well, bugger. What am I going to do about that? Okay, so what I did, I desoldered the crystal. I put it in loosely and then fitted the LumaCode board in while it was loose, so it could be pushed further to the toward this side of the board. And then once the LumaCode was in and the crystal was in, I just resoldered the crystal. So we should be good. Now, I'm going to do a quick test to make sure we're all still good on composite. And that's everything. Yes, we're still good to go on composite. Now, that I think most closely matches the aspect ratio of the composite image. But, okay, so I am going to, oh wait, need one more thing. Two more things. I need the keyboard and the worst joysticks in all history. Okay, one last thing then. We will go ahead and see about playing a game. Alrighty then. I think that'll do it. I just had to put this all back together and come up with a solution for getting the LumaCode out of the case without drilling a hole. And I think what I'm going to do is reuse the 12-volt pin on this connector here and just come out, or either reuse the 12-volt, because that makes it safe, or simply reuse the composite video pin to come out through that port there. So that will do it for this video, except for a little bit of a wrap up. And that's going to do it for today. So if you enjoyed this video, please go ahead and give it a like, thumbs up. If you didn't, you know what to do there too. But I hope you liked it, and leave me a comment below. That helps out the channel and helps the video get shared to more people. And I enjoy the interaction with you guys. I love talking to you. So yeah, leave me a comment, share the video out to your social media and to your friends who you might think would enjoy it. If you haven't already, please go ahead and click the subscribe button. And if you want to be alerted when I post new videos, click the notification bell. If you want to become a supporter of the channel, there are several ways to do that. You can click the join button below and join as a YouTube channel member. You could also go to Patreon and support me through Patreon or Ko-Fi. So until next time, stay safe and healthy, and we'll catch you in the next one. Bye.